CIET NCERT presents audiobook Curiosity, Textbook of Science for Grade 8.
Page 116. Chapter 8. Nature of Matter, Elements, Compounds and Mixtures. On the top of the page in the background, we have a scene of a school where children are busy having their lunches, playing around, or some are studying. A QR code is given on the page to scan and download contents related to the chapter. Probe and ponder. Which of the entities in the picture above consist of matter and which of them do not? How can elements be combined to form a compound? How could the discovery of a compound that absorbs carbon dioxide from the air contribute to solving environmental challenges? Share your questions. Some blank space has been provided. A picture of 3 young kids at the bottom of the page having a big question mark in their minds might be able to excite you also. Page 117. Have you ever wondered what the world around you is made of? Look around. The staircase you use, the air you breathe, the water in your bottle, the food in your lunchbox, the clothes and shoes you wear, the book you read, the trees outside, the ball you play with, and even the stick you carry. All of these are examples of matter, which you have learnt in earlier grades. You have also learnt that all these things are made up of tiny particles. Most of the things around us are not made of just one substance. Rather, they are made up of 2 or more substances mixed together. Let us now understand how different substances come together to form mixtures. 8.1. What are mixtures? Have you ever wondered what makes your poha, figure 8.1, so delicious, or how to make the perfect sprout salad? While these dishes may seem very different, they share something in common. They are both made by mixing several ingredients. We observe the mixing of substances in everyday life. Sugar dissolved in water is also a mixture, and so are soups and lemonade. When 2 or more substances are mixed, where each substance retains its properties, it is called a mixture. The individual substances that make up a mixture are called its components. The components of a mixture do not react chemically with each other. In some mixtures, the components, like green gram, chickpeas, onion, and tomato in a sprout salad, figure 8.2, are easy to observe. Such mixtures, where the different components are generally visible with the naked eye or with a magnifying device, are non-uniform in nature. Can you identify a few more examples of non-uniform mixtures around you? On the left of the page we have figure 8.1 depicting poha, figure 8.2 depicting sprout salad, and on the bottom right we have figure 8.3 depicting uniform mixture of sugar and water. On the other hand, some mixtures have components that cannot be noted separately, even with the help of a microscope. For example, sugar and water particles cannot be noted separately in their mixture. Such types of mixtures, where the components are evenly distributed and cannot be distinguished, are uniform in nature. Figure 8.3. Can you list a few uniform mixtures? Page 118. A step further. Do you know that stainless steel is also a mixture? Stainless steel contains iron, nickel, chromium, and a small amount of carbon. They are mixed so uniformly that the entire mixture appears the same throughout, and one cannot distinguish the individual substances. Such mixtures are known as alloys. Brass, a mixture of copper and zinc, and bronze, a mixture of copper and tin, are some other examples of alloys. Figure 8.4. Figure 8.4 on the right depicts utensils made of stainless steel, brass and bronze. On the left we have a picture of a girl climbing a staircase. Our scientific heritage. Mishra Loha was the name given to the mixture of two or more metals that had properties distinct from its constituent metals. Ancient Indian texts such as the Charaka Samhita, Sushrita Samhita, Ras Ratna Samuchaya, Ras Jala Nidhi, etc. mention the use of alloys for medicinal purposes. For example, bronze, also known as kansya, is an alloy made up of copper, tamra, 4 parts, and tin, that is, vanga, 1 part. It was used to improve digestion and boost immunity. There is a picture of a boy on the left who is exploring such interesting facts in a library. 8.1.1. Is air a mixture? In Curiosity Grade 6, you learnt about air and its composition in the chapter Nature's Treasures. Is air a mixture? What kind of mixture is it? You have learned that air is a uniform mixture of mainly nitrogen, oxygen, argon, carbon dioxide and water vapor. Out of these, oxygen is required by most of the living beings to stay alive. It also helps in combustion. Nitrogen, which constitutes about 78% of the air, does not take part in combustion. We also learnt that air has water vapor in it. When warm air touches a cool surface, the water vapor turns into liquid water, forming tiny droplets. Recall the experiment where you tested the presence of carbon dioxide in the air that we exhale. Let us confirm the presence of carbon dioxide in the air. Activity 8.1. Let us experiment. Take a glass tumbler and fill it half with water. Add a small amount of calcium oxide, that is quicklime, slowly to it. What do you observe? Calcium oxide reacts vigorously with water to form calcium hydroxide and releases heat. A picture on the bottom left of the page of a young scientist tells us, safety first. Perform this step carefully. Page 119. Stir continuously to make a solution of calcium hydroxide. This solution is called lime water. Filter it and observe its color. Leave this colorless solution in a petri dish for a few hours. Figure 8.5a. Keep stirring the solution at regular intervals. What do you observe? Figure 8.5b. Does it turn milky? Can you explain why the solution has turned milky? On the right of the page we have figure 8.5 depicting lime water turns milky in the presence of carbon dioxide. In figure 8.5a, this colorless solution is in a petri dish. And in figure 8.5b, the lime water turns milky in the petri dish. You know that lime water turns milky when carbon dioxide reacts with calcium hydroxide to form calcium carbonate, insoluble tiny white particles, and water, figure 8.5. Since lime water turns milky when exposed to air, this activity demonstrates the presence of carbon dioxide in the air. Calcium hydroxide plus carbon dioxide gives calcium carbonate plus water. Apart from gases, have you ever observed anything else present in the air? Have you ever noticed tiny shining particles moving in a beam of sunlight entering a dark room through a small opening? What are these particles? Activity 8.2. Let us explore. Take a black sheet of paper. Ensure that it is free from any visible dust particles. Place the black sheet of paper undisturbed near an open window. Figure 8.6a or in the garden for a few hours. What do you observe? You may notice tiny particles settled on its surface. You may use a magnifying glass to examine the particles more closely. Figure 8.6b. On the right side of the page, figure 8.6 depicts no dust particles. Figure 8.6b has dust particles. This shows that dust particles are suspended in the air. They are not an integral part of the air and are considered pollutants. The nature and the number of dust particles in the air may vary from time to time and from place to place. A step further, the major pollutants present in the air are particulate matter, dust, soot, and gases like carbon monoxide, ozone, nitrogen dioxide, and sulfur dioxide. The Air Quality Index, AQI, is a tool used to describe the air quality. On the bottom right of the page, we have the picture of a boy climbing a staircase. Page 120. 8.1.2. Types of mixtures. You know that the term mixture in common usage refers to the mixing of two or more components. The components of a mixture may themselves be mixtures, as in poha and sprout salad, or pure substances like sugar or common salt dissolved in water. However, in science, all the components of a mixture must be pure substances only. Mixtures could be of several types depending on the physical state of their components. Some mixtures with their examples are given in Table 8.1. Complete the third column. Table 8.1. Different types of mixtures. We have 4 columns in the table: serial number, mixture type, examples, and uniform or non-uniform. 1. Gas and gas. Air, uniform. 2. Gas and liquid. Aerated water, that is soda water, oxygen dissolved in water. Dash. 3. Solid and gas. Carbon particles in air. Dash. 4. Liquid and liquid. Acetic acid in water, vinegar, oil and water. Dash. 5. Solid and liquid. Sand and water, sea water. Dash. 6. Solid and solid. Baking powder, that is baking soda and tartaric acid. Alloys. Dash. Complete the column 4 wherever blank spaces are given. You learnt in earlier grades about the separation of mixtures. It is done to separate the components of a mixture. The examples discussed were from everyday life, where separation is done to obtain the component of interest and other components are discarded. However, in science, the purpose of separating a mixture is to obtain pure substances. 8.2. What are pure substances? Have you ever noticed the word pure written on the packs of some consumables such as milk, ghee, and spices? Figure 8.7. The word pure has slightly different meanings in common usage and in science. Figure 8.7 on the bottom left of the page depicts some consumable items like milk, ghee, turmeric. In common usage, pure means unadulterated products. Adulteration is an illegal process of adding substances which are cheaper or of a poor quality to a product. This is usually done to increase the quantity or reduce the manufacturing cost. However, it deteriorates the quality of the product. It can also make the product hazardous to health. Page 121. In science, however, a pure substance is the one that has no other substance present in it. For a scientist, even these products that look pure can be considered impure if they are made of more than one substance. A pure substance is a kind of matter that cannot be separated into other kinds of matter by any physical process. When a scientist says that something is pure, it means that the substance consists of the same type of particles. a step further. According to science, how would you classify milk, packed fruit juice, baking soda, sugar, and soil as mixtures or pure substances? On the right, we have a picture of a girl climbing a staircase. 8.3. What are the types of pure substances? Recall the different states of water that you studied in Curiosity Grade 6. What happened when water was cooled or heated? We observed that on cooling, water gets converted into ice, and on boiling, it gets converted into vapor. We can get back water upon heating ice or cooling water vapor. It shows that during these processes, the particles of water remain the same. Now let us perform another activity in which we pass electricity through water and observe its effect. Activity 8.3. Let us experiment. Demonstration activity. Safety first. We have on the page the picture of a young scientist protecting himself in safety gear and telling us this activity must be performed under the supervision of the teacher. Be careful while handling sulfuric acid. Do not use lithium-ion battery. Collect 2 small test tubes, a beaker or a glass tumbler, and a 9-volt battery. Fill 2/3 of the beaker with water and add a few drops of dilute sulfuric acid to it. Fill both the small test tubes completely with water taken from the beaker. Figure 8.8a. Place a 9-volt battery inside the beaker. Figure 8.8b. Without spilling the water, carefully place the water-filled test tubes on each of the terminals of the battery. Figure 8.8c. On the right of the page, we have figure 8.8a displaying test tubes filled with water. In the test tube stand, we have 2 test tubes filled with water. In figure 8.8b, we have 9-volt battery placed inside the beaker containing water. Page 122. Wait for a few minutes. Do you observe the formation of any gas bubbles at both the terminals inside the test tubes? Let it continue for 10 to 15 minutes. Observe the volume of gas collected in each test tube. Figure 8.8d. Is the volume of the gas collected the same in both the test tubes? Remove these test tubes one by one carefully. Test these gases one by bringing a burning candle close to the mouth of the test tubes. What happens in each case? Which gas is present in each test tube? On the left of the page, we have figure 8.8 demonstrating passing electricity through water. Figure 8.8c displays water-filled test tubes placing over the terminals of the battery. We can observe a water-filled test tube placed on the terminal of the battery, and we can also observe water-filled test tube placing on the terminal of the battery. Figure 8.8d displays gases collected in the test tubes. We can observe inside the beaker a 9-volt battery. There is water containing a few drops of sulfuric acid. We can observe gas bubbles in the test tube and hydrogen gas and oxygen gas inside the tubes. On the right side, there is a picture of a boy asking a question. Can these collected gases be water vapor? Below that, there is a picture of a girl telling the answer. These gases are not water vapor, otherwise they would have condensed back to form water. Let us try to identify these gases. Safety first. Again, a young scientist in protective gear tells us, perform gas testing with care. Maintain a safe distance from the setup. To test the gases present in the 2 test tubes, bring a burning candle near the mouth of each test tube. A pop sound can be heard from one, indicating the presence of hydrogen gas. Figure 8.9a. In the other test tube, the flame of the burning candle will glow brighter, confirming the presence of oxygen gas. Figure 8.9b. On the bottom of the page we have figure 8.9 demonstrating testing the nature of gas. Part A displays the presence of hydrogen gas and Part B displays the presence of oxygen. We can observe that a test tube stand has a test tube filled with water in both cases, and when burning candle is brought near the test tube, a pop sound can be heard in figure 8.9a, while in figure 8.9b the flame glows brighter. Page 123. From activity 8.3 we can infer that water is composed of two different constituents, hydrogen and oxygen. Water is made up of hydrogen plus oxygen. Ever heard of when electric current is passed through water, it breaks down into hydrogen and oxygen? Is this a chemical change or a physical change? Recall Curiosity Grade 7 chapter Changes Around Us, Physical and Chemical. We have the picture of a boy here trying to recall the same. 8.3.1 Elements. The two substances, hydrogen and oxygen, formed in activity 8.3 are pure substances and are termed as elements. Each element is made up of identical particles called atoms. These particles are different from the particles of any other element. Elements are substances that cannot be further broken down into simpler substances. They are the building blocks of all matter. Some other examples of elements are gold, silver, sulfur, carbon, etc. On the right side we have figure 8.10, depiction of molecules of Part A, hydrogen, Part B, oxygen. Also, we have the picture of a girl riding a staircase. A step further. The atoms of most of the elements cannot exist independently. Two or more such atoms combine and form a stable particle of that element called a molecule. For example, two atoms of hydrogen combine to form one molecule of hydrogen. Similarly, two atoms of oxygen combine to form one molecule of oxygen. This is depicted in figure 8.10. Elements can be classified into metals and non-metals. You have already studied that gold, silver, magnesium, iron, and aluminium are metals, whereas carbon, sulfur, hydrogen, and oxygen are non-metals. Isn't it interesting to know that some elements like silicon and boron have intermediate properties between those of metals and non-metals? They are called metalloids, about which you will learn in higher grades. A step further. The number of elements known at present is 118, and most of them exist in a solid state. 11 elements exist in a gaseous state at room temperature, all of which are non-metals like oxygen, helium, nitrogen, etc. Only 2 elements are liquid at room temperature, mercury, which is a metal, and bromine, which is a non-metal. Although gallium and caesium are solid elements, they become liquid at a temperature around 30 degrees centigrade, that is 303 Kelvin, and turn into liquid. On the bottom right of the page we have a picture of a boy climbing a staircase. Page 124. A step further. More than 45 different elements like aluminium, copper, silicon, cobalt, lithium, gold, silver, etc. are used in manufacturing a mobile phone, including its screen, battery, and other components. On the top left corner of the page we have a picture of a girl climbing a staircase. 8.3.2 Compounds. Why cannot we separate hydrogen and oxygen present in water by physical means? In water, the particles of hydrogen and oxygen are so tightly attached to each other that it is generally impossible to separate them apart using physical methods. That is why water is a compound. Compounds are formed when different elements combine in fixed ratios to form something entirely new. the properties of compounds are different from those of elements forming that compound. The constituent elements of a compound cannot be separated by any physical method. From activity 8.3, we find that molecules of water are made of two different elements, hydrogen and oxygen. Figure 8.11, combined chemically in a fixed ratio. The ratio of the number of atoms of hydrogen to oxygen in water has been found to be 2:1. On the left side, figure 8.11 gives us depiction of molecules of water. We can note oxygen and hydrogen in their integrated state. Below figure 8.11, we have a picture of a boy who is amazed by some facts. Oh, this is really fascinating. Hydrogen is a fuel. Oxygen supports combustion, whereas water extinguishes fire. Are common salt and sugar elements or compounds? Let us find out. Sodium, a soft metal, and chlorine, a hazardous gas, combine to form a harmless yet taste-enhancing substance that is essential for our lives. This substance is known as sodium chloride, which is made up of particles of sodium and chlorine in a 1:1 ratio. We learned that dissolved sodium chloride, that is common salt, may be separated from water by the physical process of evaporation. Is it possible to separate sodium chloride into its elements by physical processes? Let us now explore if we can separate the elements in sugar. Activity 8.4. Let us experiment. On the bottom left, we have the picture of a young scientist wearing protective gear and telling us, "Safety first." This activity must be performed in the presence of a teacher. Put a teaspoon of sugar in a boiling tube. Heat it gently as given in figure 8.12a. What do you observe? Page 125. As you heat the sugar, it turns brown. Figure 8.12b. Later, it begins to char, that is, it turns blackish. Figure 8.12c. On the right of the page, we have figure 8.12 depicting heating sugar in a boiling tube. Part A depicts the heating of sugar using a spirit lamp over a boiling tube, holding the tube with a test tube holder. Figure 8.12b depicts color of the sugar changing on heating. The same test tube holder holding the test tube, which is being heated by the spirit lamp, turns the sugar brown. We can also observe water droplets in the tube. Figure 8.12 part C depicts charcoal placed on a watch glass. Charcoal, that is carbon, can be clearly noted on a watch glass in the picture. Since we are heating the tube, the water must have come from the dry sugar and not from the air. Can you predict what is left behind? Charcoal, that is carbon, is left behind in the boiling tube. You can scoop it out in a watch glass, figure 8.12c, and explore if it burns like coal. Sugar decomposes on heating and gives carbon and water. As you know, water consists of hydrogen and oxygen. Hence, sugar cannot be an element. It may be stated that sugar is a chemical compound consisting of the elements carbon, hydrogen, and oxygen. Let us explore more about compounds. Activity 8.5. Let us experiment. Demonstration activity. A young scientist, all protected in a protective gear, tells, "Safety first." This activity may be demonstrated under the supervision of the teacher. It may be performed in a fume hood or a well-ventilated area. Do not inhale the gases. Take 5.6 grams of iron fillings, figure 8.13a, and 3.2 grams of sulfur powder, figure 8.13b, on a watch glass. Observe them carefully. Figure 8.13 on the bottom of the page depicts iron fillings in part A and sulfur powder in part B. Page 126. Mix them thoroughly in a watch glass. Label this mixture as sample A. Figure 8.14. Figure 8.14 on the top left of the page depicts a mixture of iron fillings and sulfur powder, which is labeled as sample A. Observe it carefully. Is this a uniform or a non-uniform mixture? Can you still observe both iron and sulfur as separate substances? Take half of sample A in a china dish and gently heat it. Figure 8.15a with continuous stirring until a black mass is formed. Let the content of the china dish cool. Place this black mass in a mortar and grind it with the help of a pestle. Now put it on another watch glass and label it as sample B. Figure 8.15b. On the left of the page we have figure 8.15. Part A depicts heating sample A and part B depicts black mass. Now you have two samples, sample A and sample B, figure 8.16a and figure 8.16b. Compare both the samples A and B step by step and record your observations in table 8.2. Figure 8.16a depicts sample A and figure 8.16b depicts sample B. Step 1. Appearance. Compare the appearance of sample A and sample B like color and texture. Step 2. Magnet test. Take a magnet and move it over the samples A, figure 8.17a and B, figure 8.17b, one by one. What do you observe? On the left of the page, towards the bottom, we have figure 8.17 depicting responses of samples A and B to a magnet. Step 3. Gas test. Take a small amount of sample A in a test tube and add a few drops of dilute hydrochloric acid. Figure 8.18a. On the bottom right of the page, a picture of a young scientist in protective gear tells us, safety first. Be careful while handling hydrochloric acid. Page 127. On the top of the page we have figure 8.18 depicting samples A and B in dilute hydrochloric acid. What do you observe? Gently smell the evolved gas by wafting it towards your nose. Figure 8.19. Figure 8.19 on the top right of the page depicts correct way to waft the fumes of an evolved gas. Test the evolved gas by bringing a burning splinter or a lighted candle near the mouth of the test tube. Figure 8.20a. Figure 8.20 in the middle of the page depicts sample A in part A and sample B in part B. A young scientist in protective gear tells us, safety first. Never smell anything directly. What do you observe? Repeat the above steps with sample B as well. Figure 8.18b and figure 8.20b. Table 8.2. Comparison of samples A and B. We have three columns. Column 1 serial number, column 2 experiment, column 3 observations, which again has two subcolumns, sample A and sample B. 1. Appearance. 1. Color. 2. Texture. 2. Magnet test. 3. Gas test. 1. Odor. 2. Burning. Write your observations in the blank spaces provided. Page 128. Some discussion points. Do the samples A and B look the same? Which sample exhibits magnetic properties? Can we separate the components of samples A and B? On adding dilute hydrochloric acid, do gases evolve in both samples A and B? In both the cases, do the gases smell the same or different? Also, categorize the substances used in this activity into mixtures, compounds, and elements. Sample A. A picture is given on the left. We can say that sample A is a mixture of the two elements iron and sulfur. Its components retain their properties and their black and yellow colored particles can be seen. On bringing magnet near sample A, the iron fillings get attracted towards the magnet. Hence, iron and sulfur can be separated. You might have observed that in sample A, iron in the mixture reacts with dilute hydrochloric acid to form iron chloride and hydrogen gas. The gas is colorless, has no smell, and burns with a pop sound. The reaction can be represented as iron plus dilute hydrochloric acid gives iron chloride plus hydrogen gas. Sulfur, on the other hand, is left as a yellow solid at the bottom of the test tube. This shows that sulfur does not react with hydrochloric acid. Sample B. We have the picture on the left. The black mass obtained in sample B is iron sulfide. We observe that the texture and the color are the same throughout. It is formed by heating the two elements, iron and sulfur. It is not attracted by a magnet. The new substance has completely different properties, and iron and sulfur can no longer be separated. Hence, we can say that a compound has been formed. Can you explain now why the magnet has no effect on sample B? Also, sample B, iron sulfide, reacts with dilute hydrochloric acid to form iron chloride and hydrogen sulfide gas. The gas is colorless and has a rotten egg-like odor. The reaction can be represented as iron sulfide plus dilute hydrochloric acid gives iron chloride plus hydrogen sulfide. 8.4. How do we use elements, compounds, and mixtures? Elements, compounds, and mixtures are all around us. The air we breathe is a mixture of gases like oxygen, nitrogen, and carbon dioxide. Water, which is essential for life, is a compound made of elements hydrogen and oxygen. Page 129. Elements like iron and aluminium are used to construct bridges, buildings, and vehicles. Understanding these concepts is not just about recognizing what surrounds us, it is also the key to innovation. For instance, chemists study how elements combine to create compounds, enabling them to invent life-saving medicines and vaccines to fight diseases. This knowledge also helps in the creation of fertilizers, thereby enhancing crop production that feeds the ever-increasing human population globally. Engineers and material scientists rely on their understanding of compounds and mixtures to design materials with unique properties. For example, they have developed alloys like stainless steel, which is stronger and more durable than pure iron. Wood, steel, and concrete, which are used as building materials, are all mixtures. You learned that various metals are obtained from minerals. Let us learn about these minerals. A step further. An example of a wonder material developed by material scientists is graphene aerogel. This is made from carbon and is said to be the lightest material on Earth. It is so light that even grass can hold it. Refer to figure 8.21, where we can observe this wonder material lying on grass. It is highly porous and therefore has a high absorbing capacity. For this reason, it can potentially be used as an environmental cleaner. For example, to clean up oil spills in both seas and on land. It is useful in fabricating energy-saving devices and special coatings for buildings. On the right side, we have a picture of a girl climbing a staircase. 8.5. What are minerals? Most rocks are a mixture of minerals, which can be viewed with the eyes or by using a magnifying glass or a microscope. Some of the minerals are called native minerals, which are pure elements and not compounds. These can be metals such as gold, silver, copper, etc., or non-metals like sulfur, carbon, etc. Most of the minerals are compounds made up of more than one element. Some common examples of minerals include quartz, calcite, mica, pyroxene, and olivine. Refer to figure 8.22 on the bottom right of the page depicting some minerals like quartz, calcite, mica, pyroxene, olivine, talc. Many things that we use in our everyday life are made up of minerals or elements extracted from minerals. For example, cement is made from calcite, quartz, alumina, and iron oxide, which are minerals or are obtained from minerals. Talcum powder is made from the mineral talc. Page 130. Our scientific heritage. Use of elements, compounds, and mixtures in Indian art. The Dhokra art is an old craft from Bihar and Odisha that uses different metals to create beautiful figures inspired by nature. Figure 8.23. The process begins with shaping a design in beeswax. This wax model is covered with clay to make a mold. After the clay hardens, the wax is melted out, leaving a hollow space. This space is then filled with molten brass or bronze, which makes Dhokra art strong and gives it a shiny golden color. The figures often show animals, people, and nature, reflecting tribal creativity and tradition. On the right we have figure 8.23 depicting Dhokra art through a wonderful, lovely animal. On the left there is a picture of an inquisitive girl searching for such content in a library. Elements and compounds are the building blocks of matter, everything that has mass and takes up space. They make the materials we see and use every day. However, not everything around us is matter. Light, heat, electricity, and even thoughts and emotions are important parts of our world, but they are not made of matter. Understanding what matter is and what it is not helps us better understand the world around us. Snapshots. On the left we have a picture of a young boy with a carry bag and a mobile clicking some snapshots. A mixture consists two or more substances mixed together. These substances retain their individual properties and do not react chemically with each other. The individual substances that make up a mixture are called its components. A pure substance consists the same type of particles. All the constituent particles of that substance behave identically. Pure substances can be either an element or a compound. Elements are the simplest substances that cannot be broken down further into simpler substances. They are the building blocks of all matter. Substances which are composed of two or more elements combined chemically in a fixed ratio and have different properties from their constituent elements are called compounds. Minerals are natural, solid substances found on the earth. They have a fixed chemical composition. Most often they are compounds, but rarely they can also be pure elements. Page 131. Keep the curiosity alive. 1. Consider the following reaction where two substances A and B combine to form a product C. A plus B gives C. Assume that A and B cannot be broken down into simpler substances by chemical reactions. Based on this information, which of the following statements is correct? 1. A, B, and C are all compounds and only C has a fixed composition. 2. C is a compound and A and B have a fixed composition. 3. A and B are compounds and C has a fixed composition. 4. A and B are elements, C is a compound and has a fixed composition. 2. Assertion: air is a mixture. Reason: a mixture is formed when two or more substances are mixed without undergoing any chemical change. 1. Both assertion and reason are true, and reason is the correct explanation for assertion. 2. Both assertion and reason are true, but reason is not the correct explanation for assertion. 3. Assertion is true, but reason is false. 4. Assertion is false, but reason is true. 3. Water, a compound, has different properties compared to those of the elements oxygen and hydrogen, from which it is formed. Justify this statement. 4. In which of the following cases are all the examples correctly matched? Give reasons in support of your answers. 1. Elements: water, nitrogen, iron, air. 2. Uniform mixtures: minerals, seawater, bronze, air. 3. Pure substances: carbon dioxide, iron, oxygen, sugar. 4. Non-uniform mixtures: air, sand, brass, muddy water. 5. Iron reacts with moist air to form iron oxide, and magnesium burns in oxygen to form magnesium oxide. Classify all the substances involved in the above reactions as elements, compounds, or mixtures with justification. Prepare some questions based on your learnings so far. Some blank space has been given. On the bottom right, we have the picture of 5 kids who are very curious, asking questions like why, when, how long, where, why not. Page 132. 6. Classify the following as elements, compounds, or mixtures in Table 8.3. Carbon dioxide, sand, seawater, magnesium oxide, muddy water, aluminium, gold, oxygen, rust, iron sulfide, glucose, air, water, fruit juice, nitrogen, sodium chloride, sulfur, hydrogen, baking soda. Table 8.3. This has 3 columns: elements, compounds, mixtures. Use the blank spaces to give your answers. Identify pure substances amongst these and list them below. A blank box titled Pure Substances is given for your answers. 7. What new substance is formed when a mixture of iron fillings and sulfur powder is heated, and how is it different from the original mixture? Also, write the word equation for the reaction. Is it possible for a substance to be classified as both an element and a compound? Explain why or why not. 9. How would our daily lives be changed if water were not a compound but a mixture of hydrogen and oxygen? 10. Analyze figure 8.24. Identify gas A. Also write the word equation of the chemical reaction. On the left we have figure 8.24, which depicts a gas formed in a test tube which has dilute hydrochloric acid and iron fillings. The test tube is standing in a test tube stand. Write the names of any 2 compounds made only from non-metals and also mention 2 uses of each of them. 12. How can gold be classified as both a mineral and a metal? Reflect on the questions framed by your friends and try to answer. Some blank space has been provided. On the bottom left of the page, we have a picture of 5 students giving their thoughts, like, I think, but we thought, maybe, shouldn't it be? Page 133. Discover, design, and debate. Design and create comic strips from real-life examples to differentiate between elements, compounds and mixtures with diagrams and illustrate their properties and uses. Search for discoveries of some elements such as phosphorus, sodium, compounds such as penicillin, and mixtures such as brass, bronze, stainless steel. Present your findings in the class. Let us search. Read labels on items like detergents or snacks and try to list the mixtures and compounds they contain. Work in groups. Each group will pretend to be in the role of either an element, a compound, or a mixture. Debate which category among them is the most important. But remember, as is depicted in this picture on the right side, science, society, and interdisciplinary projects work hand in hand. This chapter ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Grade 8. Narration, Gaurav Marwa. Sound recordist, Virendra Rawat. Assistance in production, Amarjit Sarkar. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.